My name's Andy Parsons. I'm from New York City. I'm going to talk today about disaster porn a little bit, as it was mentioned this morning at the keynote. I've done a bunch of startups in New York City over the years, and I'm going to talk about the last three. I'm kind of a glutton for punishment, so I've done maybe going on double digits now, but I'm going to talk about some that I think are particularly relevant to technology you guys might be looking at. I'm not going to go super deep on any particular topic. It's a little Postgres-centric because that's what I know. But if you want to go into more depth on anything, I'll leave time on the end for Q&A. And my hope is that you'll take some learnings away from this. Some of it you already know. Some of it, hopefully, I can shed some light and some insight on. So who am I? I don't know if anybody's seen Josh Berkus's 7 Things Not to Do in a Presentation, but this is the slide you're not supposed to have to explain who you are, but I have it anyway. Startup junkie, masochist. There's something really appealing to me about early stage startups, which is that when you start from scratch, you get to pick your tools, get to take all the learnings from the last one, however it turned out, and do something better and bigger. I've kind of prided myself over the years on being able to deliver stuff that works well in startup time without being overly hacky and difficult to maintain over time. So a lot of startups scale too early or optimize too early. A lot of startups don't scale at all and suffer the consequences. But I've been around enough to try both and fail in all the standard ways and hopefully take some learnings from it. Who am I not? I'm not a DBA. I'm not a sysadmin. So frankly, I'm a little bit intimidated by all of you, but that's okay. I'm not a super guru on all of the topics that I'm going to talk about, but I have a lot of pragmatic knowledge from a coder and a hacker and a CTO point of view. What's this talk about? I'm going to talk about some pragmatic things that I've learned and talk specifically about the problems we solved in 2 or 3 companies that I've been involved with of late. And like I said, it's a bit Postgres-centric, but it's a lot about EC2 and some of the pitfalls therein. So here are some of the recent companies I'm going to talk about. Digital Railroad. Anybody remember Digital Railroad? It's a kind of a large thing that raised a bunch of money from all the top-tier VCs, and it was designed to enable independent digital photographers to have all the tools and syndication reach that professional photographers with Getty and Corbis and those guys had. So we were responsible for basically running the businesses of photographers on our platform, and when we were down or we had latency, their business was affected. Shorty is another thing that kind of predated all the social network aggregation, all the Twitter aggregators. In 2008, 2009, and that was acquired by Collecta, which was the company that went on to be kind of the initiators of real-time web search. Outside In, anybody heard of Outside In? No? Man, I really feel out of town. Outside In is another New York startup founded by Steven Johnson, the well-known best-selling author and thinker, Union Square Ventures company, Fred Wilson on the board. And that was acquired by AOL earlier this year. And right now I'm at a company called Bookish. It's been in stealth mode for several months, and we're going to launch in October. And I'm going to talk a little bit at the end for the first time in public about what Bookish is and what we're doing. So I'm going to start with a war story, right? What better way to start? Going back to Digital Railroad a few years back. The IM you never want to get. So one of the lessons that I'm going to take out of this is that you should not allow product managers to get alerts, to get Nagios alerts. Nothing good can come of it. So yeah, 1:05 a.m., which was late at the time, especially if you have a kid who goes to bed at 1. Site's down at 1. A minute later, you're seeing all these alerts, and then the project manager says, "What does this mean? No such device. What is that bad?" Yeah, that's bad. No such device. This was a SQL server. And that's about as bad as it gets. So in fact, what we had was a single data center, but multiple layers of failure in 2 separate power zones due to a power surge and weather and a bunch of kind of odd and unfortunate coincidences. We had 2 RAID 10 devices fail catastrophically. One was the near near field backup. The other was the primary device, and backups that were going offsite were quite a bit out of date, like hours out of date, which was a big problem for us. So fallout from that experience, besides all my hair, that was the main fallout. Much of the system was down for a very short time. The team was able to bring it back quickly, but a lot of the data was old, and we had that sort of panic moment where we say, do we bring the whole thing back online and get these people, these photographers back in business? We had people who were uploading stuff via sat phone from foxholes in Afghanistan at the time. I mean, crazy stuff that really was high impact when we were down. So we had that panic moment of having to decide, make a very difficult decision about whether to come up and deal with migrating data that we accumulated through other systems, which I'll talk about in a minute, and trying to merge that data with live data, because as soon as we came up, we'd start getting new photos and new metadata, or whether to stay down and try to recover data from disk. And we decided to come back up, but of course some of that data was old, and we had to do the merge operation, which was an extremely painful but ultimately successful experience. The interesting thing is the incoming pipeline, which is what people use to upload their photos and what we use to extract metadata and kind of get them marketable as soon as possible, especially from conflict regions, was never compromised. And I'll talk about why in a second. Quick lessons learned, obvious for this crowd: don't trust expensive hardware in data centers. I made that mistake. Don't trust expensive outsourced sysadmins either. They're mostly good guys, but stuff happens, shit happens. Redundant isn't redundant enough, even with expensive hardware. And of course, cheap and plentiful trumps expensive stuff. So let me back up just a second before I go on to the next one. So the incoming data pipeline was on a bunch of commodity hardware. This was pre-cloud, and they ran Postgres, and we had a little sort of value add FTP server, FTPD, where we plugged in some Perl scripts, extracted data as files came in, and basically used a set of Postgres DBs as a cache. And when our super expensive SQL server went down, these little sort of micro Postgres instances stayed up. Enough of them stayed up and were not affected by this power issue, so that we were able to continue to take in new content when it really mattered in that particular hour of the night. Happened to be a time when there was a lot of news going on, so it was a very heavy traffic time. So in the back of my mind, I planted a seed that a bunch of small things, if architected correctly, are much better than a small amount of big things. Again, obvious, but you'd be surprised how many people don't get it. So fast forward a bit to this company, Shorty. This is a very small thing, 2 developers, one of them was me. We had some seed capital and an idea which was novel at the time, which was to aggregate lots of small pieces of data from Facebook and Twitter. Kind of the killer feature, if you're not familiar with this, was that you could declare somebody a loudmouth. This is kind of common sense now, but back many years ago, a few years ago, it wasn't. You could say, I don't want to unfollow this guy, but I want to declare him a loudmouth. So like, Tim O'Reilly has a lot of great content, but he tweets a lot, so let me sort of route his tweets somewhere else and Facebook content somewhere else. So we did that. We had a fair number of users. We had a lot of content streaming in all the time, and 2 guys and not much money to build it. So this is my first attempt to grab some EC2 instances and run a commercial grade application on EC2. The stack was a Ruby front end, very straightforward, Java crawlers and aggregators, and Postgres on EC2. So we were 3 guys with an idea and a logo when we started out, and nothing more. Built in, I think that's not quite right, something like 3 or 4 months actually, but modest traffic. We did a bunch of investor pitches. The thing stayed up around the clock, and we called that production ready, and then it was acquired by Collecta. So a success story, small, low risk. In terms of impacting people's business and lives, nothing of Digital Railroad grade or some of the things I've done subsequently, but kind of a nice success, feather in our cap, and success on EC2. Some lessons learned from that is that Postgres, if you are careful about how you deploy it, and I'll talk about some real specifics about that on EC2, works really well and can scale up to a very large capacity. It was cheap in those days. The alternative was hardware pretty much, and this was very cheap. We ran, I think at peak, something like 20 instances. Learned a very valuable lesson, which I'll also go into some detail on, which is that I/O on EC2, or any cloud provider for that matter, is massively unpredictable, and you have to plan for the worst and hope for the best. And there are some methods for approaching that. Ephemeral storage, this is an actual EC2 thing. Does anybody know what ephemeral storage is? So it really is ephemeral, right? It goes away. It doesn't always go away, but it often goes away when you least expect it. So don't make that mistake. Don't put anything important on ephemeral storage because it will vanish on you. And of course, there's no SLA in the cloud. You can look at the, on the EC2 cloud, I should say. You can look at the EC2 terms of service, and if you need something to put you to sleep, it'll do that, but it will not guarantee you any sort of uptime. Fast forward to outside in, I'm going to go into most depth on this company because it was probably one of the larger startups I've done, highest traffic, and we had all sorts of successes and learnings on EC2 and with our data stores. It doesn't sound like anybody had heard of Outside In, so I'll describe a little bit about what it is. Outside In was all about hyperlocal news, and the founders characterized it as sort of solving the pothole paradox, where a pothole on your block is very important to you. You want to be updated when that pothole gets fixed, or when somebody complains about it, or whether there's news about potholes and traffic in your area. But I may live 1,000 feet away, 2 blocks away, and that's totally immaterial news to me, not of interest whatsoever. So the idea was to really hyper-localize news and all sorts of content about venues, crime news, mainstream news, municipal information, aggregate it, geotag it using a bunch of natural language processing tools, and then present it to users in a variety of novel ways, including mobile apps, website, and also syndicate it to news outlets like 1010 Win, CBS, CNN, were all customers of ours. So we had crawlers, we had pub sub hub, hubbub types of incoming feeds, and geotagging and geo in general is very expensive to do in real time. Caching is not necessarily an option because this is news, although not necessarily breaking news. You can't cache news content for very long before you're considered stale. So we'd organize all these chunks of text of various sizes into about 100,000 neighborhoods. And then be able, at its most granular to query for news within 1,000 feet of where you might be standing. So you take your iPhone app and say, for example, real estate, show me the crime news in this neighborhood in the past month, and get a feed of that news. Which might be interesting if the broker is saying this is the safest neighborhood in Brooklyn, and your iPhone is telling you that it's a high crime neighborhood, which actually happened to me. We chose Postgres for all sorts of reasons, but the most compelling at the time was that I had PostGIS, and that was by far the most mature GIS package available for relational DB. The app I'm describing exposed an API that powers, I think it's still up there, CNN's homepage. So there's the little widget on CNN's homepage that alternately shows you stock weather and local news. All the local news came from our API. And as I mentioned earlier, it was acquired by AOL. And Patch, which is all about humans going out and collecting news, has merged with Outside In, which is all about aggregating news with machines. So this is the other slide that Josh Berkus says you're not supposed to have. I'm not going to go into too much depth, but just want to point out that we had many layers. And when you're in the cloud, you have to consider how to make every single piece of this redundant. I'm going to talk about load balancing and some of the kind of standard single points of failure and how we got past those. But in this architecture, I'll kind of talk through layer by layer how we achieved redundancy, where the more instances you have on EC2, the more likely it is that you're going to lose several of them in a given week. And we lived through a particularly painful time on EC2 where we really did lose an instance a day, literally, because of their growing pains. And their growing pains and our growing pains kind of coincided, sadly. So for a database, which is kind of often the most difficult thing to run and scale on the EC2 cloud, I'm not sure what the latest and greatest name is, but at the time, I think this is still the biggest. An M2 4X large, which is a high memory quadruple extra large. You have to think about the marketing geniuses who came up with these names, because a year from now, I'm not sure where this naming is going, but quadruple extra large sounds awesome. It's not that awesome, but it was the biggest instance at the time. 68 gigs of RAM, not massive for a database by any means. What's called, quote, high I/O performance, which has lower I/O performance than this MacBook, just to put it in perspective. 8 virtual cores, so for those who don't know how virtual cores and sort of virtual compute units are considered, and this is becoming standard across other cloud providers. You know, when you spin up a new instance, you don't know whether it's on 5-year-old hardware or 2-day-old hardware. So the notion of virtual compute units kind of abstracts the idea of what the actual underlying CPU is. That's good and bad. It makes it easy to sort of consider your cost over time for power, but it makes it difficult to actually compare OS to OS and bare metal to bare metal when you're talking about, quote, hardware. Good rule of thumb is to spin up larger instances because they tend to be on newer hardware. The exception on EC2 is micro instances, which tend to be lots of multi-tenant newer machines. But if you're spinning up small instances nowadays, you can consider that they're probably going to go away within a few weeks. Go away meaning they'll vanish on you because the hardware is old. So machines really do vanish. If you run a system, I think we were up to about, at any given time, 100 to 200 instances running our production environment. We had a smaller mirror for a QA environment and a somewhere in between size for staging environment where we would stage everything. For some services, we would do the old switcheroo trick where we had basically production-ready EC2 instances. We would stage everything and then sort of flip the switch in DNS and just swap those two environments. But machines disappear. You often don't know why. Connectivity issue will look like you'll get SSH alerts. The machine's not available. You don't know when it's going to come back. And the best your cloud provider, EC2 folks, will tell you is that, yes, indeed, the machine appears to be unreachable. Thank you. I'm going to share a funny email that some of you may have seen. If you haven't and you stick with EC2 long enough, you will get one of these. Get to that in a second. Network availability. So the Amazon infrastructure is massive. So is Google's. There are humans plugging stuff in behind the scenes all the time, and there are network outages. You have to make sure that your services can deal with a network outage, that your machines are rebootable, that you don't store anything important on ephemeral storage, because in a given week at outside in with that sort of order of magnitude of instances, we would do about 20 emergency reboots, meaning a machine was effectively down unless we rebooted it. And then for another 10 or so, I'd say we would just wait for network or the machine to come back. We gave them kind of a TTL. If they didn't come back in 2 hours, we would consider them dead and spin up another one. If storage and storage I/O are critical to you, keep in mind that you don't know what the actual physical location of the SAN is for your EBSs. EBSs are the kind of virtual disk that you get with Amazon Web Services. We had enough problems, and AWS was having enough growing pains at the time that we got an account manager, which was no small feat, for free. And through our account manager, who was fantastic, we had direct access to EC2 engineers. So I was able to get some insight into what the secret EBS actually is. If anybody wants to know, you can come talk to me afterward. It's a lot of things, as you might expect. We also learned some interesting things about elastic load balancers and what they actually are. So it was a bit better than drinking the Kool-Aid and just assuming that everything works. We were able to actually understand what the underlying software and hardware was, which was helpful as we planned for growing our infrastructure. So here's this email. I'd love to know if anyone else has seen this. There's a slightly modified variation. I don't know if anybody from AWS heard this talk of mine, or at least this part of it. But so this is saying you have an instance that's on hardware that requires maintenance. OK, cool. Concentrate on the yellow highlights. So they're telling me I'll lose network connectivity for up to 2 hours, which will occur during a 12-hour window sometime in the near future. So that basically tells me that this instance is going to go away. It might not come back, but 12 hours is a long time. This particular one, as I recall, came on a Wednesday night when we were all at a bar celebrating a release. So sometime in the next 12 hours, this thing is going to be unavailable for 2 hours, maybe 5, who knows. So this stuff happens as well. I love deploying stuff to EC2. I'm doing it again because I'm a glutton for punishment, maybe. But Bookish is based on the same thing. And I just want to point out that you have to work around these things so that when you get an email like this, you can kind of laugh it off and not be horrified and put down your scotch and run back to the office, which is what I did when I got the first one. Actually, I think I brought the scotch with me, but so, obvious tenet here, failure is absolutely assured. Load balance everything with health checks. Over the past couple of years, I've become very fond of Varnish. I know the Varnish guys are here, and I have to talk to them about something we're doing that I think is a little bit innovative at Bookish, which I'll talk about in a little bit. Use DNS. A lot of people make this mistake. So you can build a little DNS on EC2 with no problem. There are a lot of recipes for it. I have one. If anybody's interested, I can describe in detail what we did. We have OpenVPN so that engineers can basically VPN, get access to this DNS and all its routes. So we can call machines by their names. When we lose a machine, we bring up another one. We have Puppet scripts that pop it into DNS. We have Nick tools set up so we can go in and see what DNS is what. And then if it's reliable enough, meaning you have to have 2 or 3 of these DNS boxes that round robin, you can have your hosts refer to each other by their DNS names. And when you're talking about load balancing internally with Varnish or HA proxy, that's critical because you want to refer to a cluster of machines by a name, not an IP, obviously. Strongly urge people to use Puppet or Chef. I'm fond of Puppet because I found some really great guys in New York who know it backwards and forwards. If I were managing this myself, I find Chef a little bit more accessible. But the basic idea is build a hardened basic image that you probably won't have to revisit. We use the Ubuntu long service. I think it's 10.04 right now, even though 10.10 is out. We're stuck on 10.4 because it's hardened. Don't even apply security patches. Let Puppet do that for you. Reboot a few times. It may take a while for your instance to come up, but basically bootstrap everything from there. And we have Puppet scripts that install our apps. The Bookish infrastructure is about the size of outside in, meaning hundreds of instances, and we have 2 or 3 basic images that we manage, and the rest is handled by Puppet to get them where they need to be after inception. Resource contention is another huge one that bit me many times because sometimes it was just too poor to even believe. But everybody on your network needs data, and they need it immediately right now. For those familiar with Postgres, the Postgres replication before 9.0 was heavily dependent on the notion of write-ahead logs, which you would ship across, typical log shipping, ship across to your slaves, and then apply. Make sure you do any write-ahead logging in particular. Similar approaches are necessary for Mongo as well. Any heavy logging, put those on a separate physical disk, different EBS, or a local non-ephemeral disk. For example, if you boot your image from EBS, you can use that. The point is, get all of your resource I/O contention out of the way wherever possible. Keep an eye on IOStat. Again, because you don't know where your SAN volumes actually are. If you have RAID 0, RAID 10, one slow volume, which is just slow because it's on an older disk, can bring the whole thing to a screeching halt. What we had to do, which I recommend, is if you find that's the case and IOStat is just is showing you that you have questionable performance, just kill that EBS, kill that RAID set, and bring up a new one. Do that a couple times until you get the performance you like, and it'll pretty much stay there. It usually means that one of your disks is like 2 miles away and the rest are within a few feet. So get that latency where you want it, and then keep an eye on it with IOStat checks in Nagios. Not going to go into too much detail on backups here, but Postgres in particular is heavily dependent on the Linux buffer cache. So you have to be really careful about what your disk I/O, what your disk access patterns are like. Vacuuming I mentioned here because, again, in Postgres, this is a critical thing you have to do to get rid of. This is the way MVCC works. So you have old shadow rows. The vacuum process will remove those from disk. It's critical to do that often and smartly, and that is obviously an I/O-intensive operation. So you want to schedule that correctly. You might want to rely on read slaves during that time if you can. And be careful of auto vacuum, which is an automatic process that starts up on a cron job and tries to do the right thing, but when you least expect it, it will vacuum your entire database and bring things to a screeching halt as well. So I recommend some Postgres expertise. I learned the hard way about how to tune vacuum, but something to be very aware of. Again, Postgres specific. Max connections, because I/O is such a challenge with EC2 in the cloud. I recommend a connection pooler. Same goes for MySQL, I believe, but use a connection pooler whenever possible, so you can run this on your client machines that are connecting to the database. And once you max out connections, in Postgres in particular, a connection has a working set and can use up a ton of RAM, so letting connections grow without bound and doing the standard thing, standard reactive thing, which is 150 connections weren't enough, let me bump that up to 200. Well, guess what? Next week, 200 isn't enough, so bump that up to 250. Eventually, you're going to run out of RAM just because if you have idle connections, they're eating up a ton of working space. I've become fond of PG Bouncer, which is a common one. If you're familiar with PG Bouncer or considering PG Bouncer for pooling, be careful of the 3 modes in which it works. I'm not going to go into too much detail here, but there's an aggressive mode and there's a less aggressive mode. Session mode is the life of the connection, which can be useful in some cases. Transaction mode is an attempt to sort of apply heuristics to figure out when your transaction starts and ends and return the connection after that. And then statement mode can be difficult because you may get a connection, execute a statement, intend to execute additional statements, but your connection is gone. And lots of interesting war stories around that one. Back to the specific problem of outside in, where we had to consider doing all this mathematically CPU-intense containment calculation. So to figure out what news was within 1,000 feet of me, I had to first locate myself, then project upward and figure out what neighborhood I'm in, what state I'm in, what township, all the way up to the country level in order to aggregate news correctly. And we allowed you to zoom in and out all the way down to the block level, essentially. So points detected in text, be it a venue or a block or an intersection, had to be placed into neighborhoods properly. Neighborhood boundary data, Yahoo or Maponics or some of these companies will tell you exactly where all the neighborhood boundaries are until you talk to a neighbor in the actual neighborhood. It will say, no, that's the other side of the tracks. That's not my town. The boundary is by the river or the boundary is by the train tracks. So we had a need to kind of redraw boundaries quite frequently when we would go into a new market, especially for kind of the white labeled product that we licensed to news organizations. They would say, we know this is the standard Tiger shape data, but it's wrong. We're the experts. We live here. So whereas you'd think it might be easy to cache those shapes, simplify shapes, shape data is complex by nature, and then just sort of leave it and cache the crap out of it. In fact, we had a lot of need to recalculate containment. So once you acquired a lot of news in a particular area, then recalculated, basically remapped boundaries for neighborhoods or townships, municipal boundaries, we had to basically recalculate all those points and recontain them. So another problem is that adds to the CPU intensiveness of this issue is that shape data overlaps. As soon as you get it from a single source, you have overlapping shape data. Towns don't really match up exactly like a jigsaw puzzle. They overlap. Some of them go into bodies of water. We found townships in New Jersey that extend quite far into the Hudson River, which we thought was interesting. I think probably for the purposes of collecting tax dollars on fish, or I'm not sure exactly why that is, but Manhattan actually extends well into the Hudson and the East River as well. So we had to do some percentage overlap calculations to figure out whether these, basically how to clean up this messy shape data. As I mentioned, containment projects upward. Point is, all of this shape data is very messy and not able to be dealt with in real time. And that's because geometry is slow. So even with PostGIS, as awesome as it is, you can't really do these intersection and containment tests in real time when a guy's standing on his iPhone trying to find out what crime information is available within 1,000 feet. Excuse me. So we had to avoid all these complex geoqueries and do something smarter. This sort of lesson goes for any infrastructure, particularly exacerbated by EC2 I/O constraints, which I mentioned earlier. So what we ended up doing to solve this is to cache everything we could. Because we had a lot of textual data and text-based search infrastructure, which was based on Solr and Lucene, we decided to denormalize all of this containment data into Lucene, where the final data was going to end up. So that for a given piece of content, we could basically have denormalized all of its projections up and be able to search on it using Lucene lexical semantics and range queries. So we use PostGIS on a separate set of hardware, more expensive instances, fastest possible RAID for generating and updating what we call the content cache. And then we cached it through kind of a denormalized Postgres table, which we would then incrementally index. So that at any given time, when a news story came in, was geotagged to a certain point or a certain region, that would flow through the system very quickly so that readers of that data would never be penalized. Then came our awesome strategic investor and partner, CNN. So we thought we had a good thing going with end users, customers, smallish markets through CBS affiliates and things like that. And then along came CNN and said, hey, we want to put you guys on our homepage. And what? You're hosted on EC2? Well, good luck with that. Let's talk about a data center for you guys and how we're going to use all our dollars to invest in that. And I said, no, give us a chance, give us a few weeks to build this API. At this point, we had kind of migrated a lot of the heavy lifting out of Ruby. Outside In started as many startups do with a monolithic Ruby app and a monolithic relational database. In addition to introducing Lucene and a lot of denormalization across the thing and eventually Mongo, we introduced Scala and the JVM for a lot of the heavy lifting in code, sort of data switching and aggregation. So we said, OK, we'll build this API, this nice REST API. We'll put it behind Mastery, and we'll see if we can handle this load. Obviously, CNN, I don't have the exact numbers. I used to have it off the top of my head, but millions and millions of page views, hundreds of thousands of requests per second, sometimes on single clustered server, single endpoint. And as I mentioned earlier, news, particularly in this case, where you're sitting there on the CNN homepage, where that section of content is exposed, I think, before and after the stock market close, is very sensitive to caching. So this is newsworthy stuff that you can't cache for very long, minutes at best. What did we do? We looked at our Postgres database. We decided to replicate the crap out of it to further speed up that process of receiving content, parsing it, putting it in the database, and then fanning it out to a denormalized structure, which is basically a row for every containment that the particular piece of text contained, and then push it into a cluster of Lucene databases. In Postgres 8, you only had what was called warm standby. Postgres 9 has, I think it's called hot standby, actually, but it's basically streaming replication, which, of course, MySQL has had for decades. So just when I was ready to give up on Postgres, Postgres 9 came along and added streaming replication. So very exciting. We're using it at my new company, Bookish. So that meant that you had to be very careful about this EC2 issue with wall shipping, storing logs locally on a separate disk, sometimes multiple disks, and then shipping them across as quickly as possible and applying them. And monitoring very closely. We had a bunch of Nagios alerts that our Postgres consultants helped with so that we could know exactly when a backup had gone wrong, exactly when wall shipping had to be replayed. And we had quite a few problems before we worked out the details of that for CNN scale. One of the things I've only seen on EC2, and nobody has been able to explain it to my satisfaction, despite lots of research, is we would have replicas come out of standby mode. This is not such an issue anymore with hot standbys, but if a replica comes out of standby mode, it means that it thinks it's ready to be a master. Warm standbys aren't queryable, so what we would do is take some of them out with this cache content on purpose and make them available. But we'd have replicas that we didn't want to come out of standby mode suddenly come out of standby mode and be unavailable for log shipping and such. Some of the Postgres gurus we talked to blamed EC2 weird disk I/O and lack of IOPS. Others said it was network connectivity. So we were never able to reproduce it when we wanted to, but sure enough, on many Saturday nights, without wanting it to, this would happen. So this is sort of a moot point, but if you're still doing write-ahead log shipping, something to be aware of that can happen. A little bit about backup there, just see how I'm doing on time. So one quick thing on backup, without too much detail on this, specific to EC2 and other cloud providers, as I understand it, we started doing larger and larger backups at night. So this was two kinds of backup. We do a binary backup and then a Postgres dump, which is kind of a SQL statement backup, and push that all up to S3. And that got slower and slower and slower. Then we took some of these replicas, which were ostensibly smaller with some of the denormalized data, and backed those up, and they were taking longer than the larger databases did the week before. And we looked at why that might be, and at the time talked to some friends at Foursquare and some of the other guys in the Union Square companies. What basically turned out to have happened is that everybody raised money around the same time. Everybody spun up lots of EC2 instances from their kind of smallish footprint to a bigger footprint because they raised money and were getting bigger. And everybody on the East Coast was doing backups at the same time overnight. And everybody was suffering the consequences. So sure enough, we moved our backups by a few hours, staggered them, and everything was back to normal. So My impression is this is still happening, although my new company, Bookish, is not live yet. We're doing sizable backups. We have a massive catalog of all books in print and lots of metadata that goes with it. And those backups are taking longer than they should, and they're happening at 3 in the morning. So when I get back to New York, we're going to move that to 7 in the morning or something East Coast time. So all these things are in Virginia, massive, crazy saturation with EC2 I/O at that time. So don't do your backups at night if you can avoid it. In terms of faster backups, there have been experiments which, some successful, some not successful. In my case, not successful, doing file system RAID snapshotting. So if you have an array of 4 disks, in theory, you can do an XFS snapshot, EBS snapshot, store that, and restore the RAID array. I see some blank stares. I had the same kind of sense that this couldn't possibly work. So I've seen it work in a very contrived situation. In EC2 recommended against it for a while. Now the engineers we talked to were like, well, it could work, but it's not something we would ever support. So be careful with that. A good idea is if you have something large to back up, create a massive, a terabyte or whatever EBS volume, move your data there just for the purpose of taking a snapshot, and snapshot that as often as you wish, and use that. Restoring that could be another matter if you have a big monolithic backup, but snapshotting RAID, although in theory it could work, even if you freeze the file system, is not recommended, in my opinion. Load balancing, here's another interesting one to share with you that we learned from talking to EC2 engineers. Anybody try to use elastic load balancers? So this is a very common and easy way. You spin up an ELB, you say it gets an IP, and you put a bunch of instances behind it. They get a little health check. So of course, behind the scenes, this software is actually HA proxy. And what AWS tells you will happen is when your traffic scales up, we will grow the cluster so that there's more CPU, more bandwidth to load balance to your customers. The intent is that it's a front-facing load balancer, and that's that. And it seems to work really well if you have geographically distributed traffic and lots of IPs coming in, typical web application front end. And it'll drop your instances if they're not healthy or if they go away. It works pretty well. What we attempted to do, and many others have, is to take that kind of ease of use goodness and apply it to internal load balancing. So we had web servers in that big architecture diagram I drew. We had a lot of services, API services that were intended to be internal only, not to be exposed outside. And we said, let's take an ELB and put it in front of those, and we'll get the same kind of HA proxy elasticity that we get for our front-end Rails servers. We found that wasn't the case at all. We were able to saturate them. They didn't seem to grow their capacity at all when we hit them with a lot of load. And we had drop connections all over the place where the backing instances, the API servers were barely breathing, and these supposed HA proxies would be totally saturated and flipping out. So when we finally got to the bottom is the reason that this is not recommended and can't possibly work is because the load balancing heuristic is, or I should say the capacity heuristic for adding EC2 instances to that HA proxy cluster is based on distinct IPs. So when you're coming at an ELB from internally with, say, 5, 10 .IP addresses instead of hundreds or thousands of consumer IP addresses, it just doesn't work. It doesn't scale. You can crash it. In fact, we were able to make one go away, which you're not supposed to be able to do. So from the horse's mouth, although it's HA proxy, it doesn't behave the way you want it to for internal load balancing. And that's still the case. So don't do that. That was a big battle scar. We had a particular unfortunate falling out with some of our CNN folks over that one. Totally my fault. Instead, we put varnish caches in place and did something clever with DNS so that if one of the varnish proxies went down, they're all just plain old EC2 instances as well. If one of those went away, we would sort of balance it out of rotation using very low TTL and DNS. Talked a little about this. I'm going to skip some slides because these go into more detail, and I want to leave a minute for questions. EBS file system tests. I urge everybody to do this on their own. So when you're creating RAID and you're looking at scheduler and stripe size and all those kinds of things, EC2 hardware is constantly changing from underneath you. So if you're about to go live with a Postgres database or a Mongo database that needs RAID or whatever, do these kinds of tests on your own. We have some scripts. We worked with some folks at Endpoint who helped us with this. And I think there's a blog post about the particular exercise we did. We tested all of these various combinations of RAID 0. We didn't use RAID 10 at the time, but it is recommended now. We found that XFS with 128K stripe and the deadline scheduler although a somewhat unintuitive combination with 4 disks was the best bang for the buck in terms of I/O. And I've stuck with that, although I intend to, before we launch Bookish, to do this test again and see what's changed. I think these slides will be shared, so that's good information that I'd love to have people not to repeat, but I urge you to do your own tests. This is more Postgres detail I'm going to skip in the interest of time. Here's a good one. So this is heinous. This is the heinous SQL slide. I'm only showing it because it's my favorite slide in this slide deck. This is real SQL for some of the denormalized geometry caching that we used. And this particular query was used to index some stuff into Lucene. All of the challenges I've talked to up to this point kind of culminated with this particular SQL statement. It is well written despite its verbosity and insanity. It is actually quite efficient. And a lot of people look at this and study it and optimize it. And all of the techniques I've described thus far were used to basically make this thing fast. So we had to look at Linux buffer cache behavior, size of the instance, disk I/O, putting stuff on separate disks, and we were able to make this run fast enough. So how do we make the heinous SQL, I almost said the famous heinous SQL run fast, less than 250 milliseconds. Feed the query planner in Postgres tons of stats. Sometimes it doesn't know what to make of a raw SQL query, so there are these things called buckets. Again, I won't go into too much detail, but sometimes you have to rewrite queries in unintuitive ways because one of the Postgres team's core mantras is that the query planner knows better than you. And in my experience, that's usually the case, but because it knows better than me, it sometimes does some quirky things, and we have an argument. Last thing, just in terms of not necessarily EC2 specific, but everybody talks about this. You know, when you're talking to your board of directors or your raised VC cache, they say, really, cloud? Why don't you think about a data center? You know, clouds are expensive, always getting more expensive. We're concerned about the increased costs and lock-in and things like that. So there is naturally an inflection point where if you're 100% cloud, if you're Foursquare or Bookish or somebody who's getting pretty big, there is an inflection point where it probably makes sense to consider some hardware and VPN connection or all hardware. You know, this point will come eventually. It's inevitable. But you can kind of extend your lifetime on the cloud, contain your kind of cost overhead by looking at reserved instances. Everybody has a sort of variation on this, but the idea is you pay ahead for a certain amount of capacity you know you're going to use for these instead of using on-demand instances, and that inflection point can kind of move way out into the future. You drop some cash for 1 or 3 year reservation, and your hourly costs go way down. One good thing to keep in mind, in my experience, we found that for a 1 year reservation, it took about 6 months to kind of recoup that cost if you kept all your instances running. And my advice is if you have reservations on EC2, just make sure they're always in use. For anyone that's not in use, you're losing money. That's kind of what that slide is all about. I'll talk for 2 seconds about Bookish. Bookish has been in stealth mode. Used to be called Obacash, which is a super clever anagram. Get it? Obacash. Bookish is basically a joint venture between 3 of the biggest publishers in the country, and we have pretty much every major book publisher signed up as partners. As partners, they give us interesting access to metadata about books and actual ebook content. And we do a bunch of interesting things around analyzing the ebook content, producing editorial that's linked to specific ebook content. And in October, we're going to launch with a website shortly thereafter with mobile apps that sort of enhance the reading experience, open platform, not Kindle or Nook or anything else, or Adobe DRM specific, more open platform for reading and providing users information about books. That's kind of the generic elevator pitch, and I urge you to sign up and get an invite and check it out. So here's what we're trying here. Again, another chance to start from scratch after a great success with Outside In and its acquisition by AOL. This data layer is a hybrid Postgres, MongoDB, and Solr data stack, a variation of what I have tried before and been successful with. We have a lot of relational catalog data that Postgres is perfect for. We have a lot of social graph data that MongoDB is ideal for, where you're just denormalizing from the get-go. And then we have Solr, which continues to impress in terms of performance when you use it for the right things. Front-end Rails app, again, a Scala backend, API-based, kind of service-oriented architecture, but I wouldn't quite call it that. We have Sprout Core apps for kind of JavaScript inside applications on iOS and Android. Redis and Rescue for queuing and caching. Postgres 9, so we have nice streaming replication, which is fantastic and kind of a core piece of the catalog architecture. We use UUIDs and kind of a ID oracle for marrying all these things together for immutable things in the system, like users, books, authors, and a bunch of other things. We're doing sharding with replica sets, so although the full Mongo componentry takes something like 11 instances to be properly redundant, we've in consultation with 10gen, we're going even bigger for this because we anticipate a ton of data and learning from the Foursquare issues of several months ago, and then several months before that. We're trying to kind of do the best we can for ourselves on EC2 with these lots of data stuff. Looks like we're going to end up with about 200 instances for production at the capacity we're planning. This is a consumer site. We're launching next month. Everybody tells me I have to say we're hiring, so we're hiring. If you're in New York or remote or whatever and have interest, please contact me. So that was kind of, I don't have any lessons learned from Bookish yet because it's mercifully still in stealth mode and not launched. But in a month, we'll see the shit hit the fan. No, it's going to be great. Invite me back next year, and I'll tell you all about what actually happened. So that was sort of a roundabout disaster porn / hopefully informative, insightful things about running various services on EC2. I have a few minutes for questions. Anybody have any questions? Yep. The question is, did we test ext4 on that list of file systems? It's a good question. Let me look back at it. I don't think it is on the list. No, ext3. And I'm not sure why that's the case, but if I were doing it again now, which I am, I would test ext4. We have decided on ext4 for Mongo because it's much better for allocating giant initial allocations for Mongo collections. So ext4, that's another thing I wanted to mention, which we just discovered through testing, and it's recommended by 10gen. ext4 is far superior to ext3 for just about anything. Anybody else? For the Mongo setup? The question is, did we have, when I said 11 instances, yeah, 11 is kind of, you want replica sets to come in threes, basically, because when one dies, they want to have a majority to elect the new master. So that's 9 for a basic sharded set of 3 shards, where you kind of round robin your shard keys. Then you have a dedicated Mongo S and a config server. Our standard, one of those 3 basic 64-bit instances is an M1 extra large, whatever that is. So that's what we're using. Any other questions? Okay, thank you very much. I hope that, oh, one more? What about, I'm sorry, EBS? Yeah, so I mean, basically, we learned about specific vendors. I'm not going to mention those because we ended up having issues, it seemed like, with a specific vendor of clustered storage. But we learned a lot about, we learned a bit about how routing is done and how you actually make, your EBS may actually be on a SAN that's practically in another data center across the campus. And the kinds of latencies, 50 plus milliseconds latency minimum to get outside the building. And that, in fact, you could have anywhere from 1 to 3 to, in one case, 8 hops to get to it. So it explains a lot of the latency and I/O contention that you seem to have, even though you might have a new fast disk. It may be actually located remotely. So that's basically what we learned.
Have you evaluated any cloud services like Terramark?
Not Terramark. The question is, have I evaluated any other cloud services? No, I'm blanking on the name of the other guys we looked at. Rackspace Cloud, yes. No. Sorry. No. Unbelievable. I was just talking to somebody about this morning. Yeah, we did a cost comparison. It came down to my comfort level with trying something new at Bookish. And we did some cost comparisons based on my desire to have no more than 3 kind of instance types that we would bootstrap. Simplicity of doing that and the ability to have instances with a fair amount of RAM, like 68 plus gigs of RAM. So we ended up sticking with EC2 for that reason. And for all my complaints, I think EC2 is fantastic, don't get me wrong. There's a lot of people nipping at their heels. But at the end of the day, the devil you know is maybe better than the devil you don't know. So I was a little gun shy about that. Yep. Can you go back to ephemeral storage for them? No, ephemeral storage is bad. It's all bad. Never use it. But the question is, can you not use RAID under those Mongo instances? Is that? Oh, I see. Yeah. So uh-huh. Yeah. So I mean, we're doing RAID 0 there. We're not doing RAID 10, which would be a mirror and the ability to recover from a volume disaster. But RAID 0 is there for I/O, not for redundancy. So that's pure. You're not going to get enough I/O for Mongo's satisfaction. Now, Mongo obviously works best when everything's in RAM. They warn you quite clearly about trying to keep everything in RAM. But any disk I/O on a mission-critical system, whether you have it replicated 5 times or 100 times, can benefit from RAID. And it's very inexpensive, and there are lots of recipes for setting up a nice RAID 0 like we did on our XFS volumes. So you should do it. OK, thank you very much. Hope that was helpful.